Hi, I'm Avi. I'm an engineer in Earth Engine for the past 3 months. So as I was telling Olga, if any of your scripts don't work, it's not my fault. But for next year, you can totally blame me if something doesn't work. So welcome to these lightning talks. We're going to talk about engaging the community. These 10 speakers have done incredible work on biodiversity, conservation, restoration, all through engaging with community stakeholders. I think my only relevant experience is I've been to community board meetings to try to get people to put bike lanes in, and that's contentious enough. So the ambitious work that these guys did is incredible. We have 10 speakers here. I've been given very strict instructions about the rules. Everybody has, how long is it, 5 minutes to talk? 5 minutes to talk. Steve over there in the front is going to enforce that very strictly. He's got signs for a minute, and then applause for when people are done. Yeah, we don't really have time for questions during the talks, but hopefully everybody here will stick around afterwards, and we'll just be here for the rest of the conference. So if you have any questions, just go introduce yourselves. In my few-minute interactions with them, they all seem very nice, so feel free to go say hi. Rachel. Rachel is a geospatial analyst working for the Wilderness Society, which is an environmental NGO in Australia. You've been working in GIS and Earth observation for 15 years. That's 14 years and 9 months longer than me. And she's going to be speaking to us about a citizen science platform called Watch on Nature. So, Rachel Fletcher.
Thank you, Avi. To start with, I'm going to quickly talk about the environmental issue of deforestation in Australia, because some people here might not know that according to WWF, Australia is a deforestation front, along with the Congo, Brazil, Borneo, etc. The rate of deforestation, including sparse woody vegetation, in Australia over the last 5 years is over 11 million hectares. The drivers of this include beef, cropping, timber, paper, pulp, and bauxite. Obviously, like the rest of the world, the impacts of deforestation in Australia include climate impacts and habitat loss, leading to species extinction. Also, the highest deforestation rate is in the state of Queensland, whose land mass feeds runoff from cleared pastoral stations into the Great Barrier Reef, polluting this very important World Heritage Area. Unfortunately, many people don't know the extent of deforestation and land clearing in Australia, even Australians. This is because Australia is massive, 7.7 million kilometres squared, which is nearly the size of the USA, with its small population mostly living on the coast, while deforestation is happening where the general public can't see it. Australia's crisis is going unnoticed globally for a few reasons, but the major one is that most global efforts are focused on the tropics, as they should be, but this leaves places like Australia that need special technical attention under-monitored. The monitoring tools built for the tropics have really high false positives in sparse woody vegetation. A lot of Australia is covered in savanna or sparse woodlands, but not all of it. Even our denser forests get the high rates of false positives in auto-change detection models and need a lot of training data. Australia also has natural vegetation natural variations in the reflectance of our vegetation, making it hard to run a single change model over the continent with accuracy. Leaves dry and grow back at different times, and using August to August reduces this, but does not reduce the high level of human verification still required for accurate results. We also lack training data at a national scale. Our solution was to build a citizen science platform to enable us to monitor vegetation change in near real time with community effort, and use that human-verified vector data to train and build better auto-change detection. Sentinel-2 imagery from Google Earth Engine allows us to do this nearly for free, and we also use a few APIs in our back end and front end, including Google Maps API, Geocode API, and others. We use Watch on Nature not only to provide the community and conservation movement with near real-time imagery in an easy-to-use interface, but also to expose and communicate the issue to the public to increase awareness. We send drones out to get footage of deforestation as it's happening, And our platform sometimes allows us to actually get bulldozers in action. This is powerful for our campaigns as it brings to life the reality of the issue to viewers. We also use Watch on Nature to develop better auto change detection. The data from Watch on Nature currently contains over 1,500 polygons that can be used as training data for machine learning and AI. The platform has basic auto change in it, and our next development stage is to improve the methodology for Australian environment, including savanna, that will guide users to probable deforestation events by possibly looking at the Vertex AI using the connector that's now offered by Google Earth Engine. A brief summary of the process of Watch on Nature is that citizen scientists and community members monitor the area for change over a series of dates, at least 2, draw around the change and submit to the platform, including the start and end dates, and those are verified by Earth observation scientists. The data is added to the database and used for various analysis and developments, including training data, other analysis, and drone footage. This is what Watch on Nature looks like, and you can see those verified change polygons there in pink that have been submitted by our volunteers, citizen scientists for this particular AOI since March this year. We have multiple AOIs across Australia that we're monitoring, and this number is growing. Watch on Nature also has free roam anywhere in Australia using Google Earth Engine loaded on the fly. The whole platform runs off Google Earth Engine's data repository, APIs, and exceptional processing power that we can export data for quick loading and display data on the fly in the platform. Upgrading our auto change detection is where we will be focusing our attention over the next 6 months. We will also use Google Maps platform APIs in our front end and store some outputs on the Google Cloud platform. Our impacts so far have been very positive, with various deforestation events being taken to court and others being looked at by the authorities, and we send the details to the regulator. The platform has been offered to other ENGOs to conduct their own monitoring projects and to First Nations community groups for monitoring country remotely, especially fire and activities that they have not been consulted on. We have also sent 1,500 polygons to a geospatial team in Australia to use as training data for a project underway to provide a method for auto detection across Australia. Come out and check our demo station this evening for some drone imagery that we have acquired by using Watch on Nature through citizen science. Thank you.
Thank you, Rachel. That was really cool. Actually, reading your slides, I realized I didn't really know that Australia was so forested. I sort of picture the, like, I don't know, red, sandy middle of the country, I guess. But when we were doing fire monitoring, they kept being like, Australia has tons of wildfires. We need to do that there. It's like, what if the sand catch fire? But it turns out there's a lot of forests. But I'm an American. I should know more about other countries. Here we go. Oh, our second speaker is Sophia Lin from Colorado State University. She has my favorite title I've ever heard. Her title is Head of Geospatial Centroid, which I thought sounds like you're the dictator of Earth. But it turns out that the Centroid is a geospatial resource and service center for supporting researchers and off-campus clients at CSU. She's been involved with tons of projects in different disciplines, and she spent over 20 years improving geography education, which is amazing. And you're going to be talking to us about a beautiful Greek island? Okay, people like hearing about that.
I have to do this. I have to do multiple things to hold this up. I got to figure out how all this is working. All right. So over the past few years, we've all learned that remote work is certainly possible. And at this summit, we are well aware of how remote sensing makes Earth's system more visible, even from afar. But this is the story of how remote work and remote sensing, as well as other spatial technologies, help support conservation efforts on a remote island in the Inner Ionian Sea. Where's the down? Oh, the clicker? Big button. Big button. Big button. Don't include this time. Maybe.
It's the biggest button?
Biggest button. Let's see if we can go down. Forward, slide. How about?
Oh, wait, I see what happened.
There we go. Okay, thank you. Don't count that as my time. All right, thanks. So Kalamos is not on the way to anywhere. It's a 5-hour bus ride from Athens, followed by a 30-minute boat ride, both of which happen only once a day. Despite this relative isolation, its current situation is primarily a result of actions, decisions, and influence from afar, remote, you could say. So, a little bit of context. Historically, the area around the Inner Ionian Sea had sufficient resources to support thousands of people who lived on the islands and along the coast, with each community contributing to a functioning local economy as well as its governance. Some communities provided fish, others wood products from the nearby forests, and herders provided animal products. In the words of an old-timer who grew up on the island, the sea used to boil with fish. So what happened? Well, the 20th century was rather tumultuous in Europe, and Greece certainly felt the impact of both the First and Second World Wars, not to mention its own civil war. Decisions made from afar influenced where refugees were settled and how a hungry population could be fed. In this region, refugee settlements disrupted existing systems of production and trade that had been sustained for centuries. Equally as disruptive, new fishing methods, including trawling and dynamite, came in from afar, and while they may have been efficient in gathering fish, they decimated the sea for decades to come. So what's the current situation? By Greek standards, this area is relatively underdeveloped with a rather sparse population. Only about 500 year-round residents live on the island of Kalamos, and as such, it has no local representation in government. It is part of the prefecture of Lefkada, which is a much larger island with entirely different issues of concern. There is minimal tourism, primarily sailors cruising through the crystal blue waters of the Ionian Sea. As for the environment, according to one sailor I met, this sea is dead, meaning they saw little to no marine life. Even still, there remain conflicting values about how the land and sea should be managed. Should it be left alone to be rewilded and serve as an example for natural restoration, or should other beneficial uses be allowed here, for instance, renewable energy or fish farms, both of which could benefit those far away? A small nonprofit organization called Terra Silvestris has the mission of reestablishing local control in this area and also of enabling this area to come back to life through rewilding. So how did I come to work here? I live in Fort Collins, totally remote, landlocked place. Well, in the summer of 2018, I volunteered with Terra Silvestris and spent a couple of weeks on this island, providing mapping support related to estimating seagrass, mapping locations of fish farms, and beginning to build a collection of spatial data. I returned the following summer with 3 students from the Geospatial Centroid at CSU, and that summer we focused on georeferencing aerial imagery from the 1940s, digitizing participatory sketches, participatory mapping sketches, and collecting drone footage. COVID, of course, put a stop to subsequent visits, but I hope to take a few more students there this year. Although I've contributed to a number of mapping tasks over the years, I'll just share 2 examples. So the first year I was tasked with finding a better way to calculate the extent of seagrass, or Posidonia oceanica, around the island. Although maps of seagrass existed, they were at the national scale, where 1 pixel equaled 1 kilometer. So on the left hand, you can see that. When an island is less than 10 kilometers long, a 1 kilometer pixel is not terribly useful. But at the other extreme, volunteers were sent into the water to count seagrass stems, which was not very efficient either. So we needed an intermediate scale. So using an established grid like this and Google Earth imagery, we got volunteers to estimate the percent coverage of seagrass at the 1 meter scale as opposed to 1 kilometer. Another project involved gathering disparate data sets, including remembrances of historic fishing grounds, as well as georeferencing maps from the last century showing where nomadic routes on the mainland were. So this I did from my office in Fort Collins, and yet, interestingly, its impact was felt locally. In fact, I was told that a wind farm had been proposed on the mainland, and the consultants doing the environmental impact assessment stated that there was no prior or current use on these hills. The maps of the nomadic routes were presented demonstrating prior and current use, thereby somewhat negating that assessment. I understand the plan was scrapped on that land. So the fate of this small corner of the world ought to depend on local decisions. Yet from afar, I intend to contribute by recording, mapping, and visualizing its past and present using the tools and technologies we all have available to us.
It was beautiful. Thank you. Hopefully, if Google adjusts their remote work policy, I would love to join you. Our third speaker is William Sinea, an entrepreneur and a naturalist with a passion for sustainable development. And this is really cool. In 2003, he founded the Botanical Gardens of Lekaya with an initial investment of just under $50. And it's grown into a premier center for botanical research, conservation, and education in Haiti. Various Google reviews describe it as beautiful, peaceful, and romantic. So, good job. He was also recently honored as a Kinship Fellow in recognition of his exceptional leadership and contributions to conservation. William?
Thank you so much. Good afternoon. Before starting, I would like to give you a context about why I started Botanical Garden and why I'm involved in question of my map. In 2000, I graduated in forestry in Dominican Republic. I go back in my country. So as a forester, I start a nursery. I didn't have the money at this time to buy the equipment for the nursery. I went to the street, collect some pots, and start my nursery. A lot of people think I was crazy. My family was very skeptical about me. They say, it's so strange, a person coming from another country and coming in the street, collecting pots in the street. They think I was crazy. But in 2003, I had the opportunity to go to Israel. I visited this beautiful garden, the Baha Garden. And they say Israel doesn't have water, they don't have species. And I say, we have more than them. So I said, I can do this garden too. Going back to Haiti in 2003, and I went 8 hectares of land to start the beautiful garden I saw in Israel. 4 years later, I create one of the beautiful gardens in Haiti. So that's now a photo that's in 2003. So the story doesn't finish here. I was a gardener or a landscaper, but I didn't understand research and conservation. In 2009, I went to Kew Garden. I studied botanic garden management at Kew Garden. When I was there, I visited Oxford Botanical Garden, Cambridge Botanical Garden. At this time, I understand botanical garden is not only a place for showing beauty, but it is a place for conservation and research. And coming back in Haiti, this is my staff. I built a good research department in the garden. They are doing research all over in Haiti. We collect a lot of data on seeds, herbarium, everything like that. So what we did with all this data? So with my map, now we use it to convince the government, to convince the NGO, to help people to understand what they have around them. Haiti is the second country in the Caribbean with most diverse plants, but nobody knows that. When I grow up, I fire them, I cut them down because I didn't know about that. So today with my map, we collect or we map every natural area in Haiti that they need to do restoration. But one thing that's really keep my heart is during the COVID. They say stay at home, but most of Haitians using medicinal plants for the COVID, but they don't know where they are. Nowadays, I try to map every medicinal plant when something happens like that to know where they are. We have big hurricane or earthquake in Haiti. When we have that, we don't have hospital, we don't have doctors. So we need to know our plants. Nowadays, this is my job. And the second thing is to look all the plants that can resist and build resilience for the country. I did all of that based on not just simple, but I have some discipline that helped me to develop my leadership and entrepreneurship. The first is awareness. And I know today you don't know about plants. There are more than 300 to 350,000 species. You don't know 20. I'm sure you don't know 20. So my job today is help you to understand nature, to understand plants. So I am constantly learning. That's the understanding. I travel a lot, take a lot of classes to improve my knowledge on plants. And today I know that I know a lot of things about plants. And the third is dissociation. Dissociation, it's I don't let my limited belief to block me to do what I am doing. I focus on what I am doing because I know I have to mobilize people in my country. I have to make things happen. And I will condition myself. That means every day, William Sinea is another person. And I believe you are doing a lot of projects. We can continue to do projects together and make the world a better place. Thank you.
Thank you. It's a beautiful botanical garden. Our fourth speaker is Esme Mulder. She's a program manager at MetaMeta, which is not a Facebook subsidiary, but it's a Dutch environmental NGO that works to promote sustainable land and water management. She's very passionate about bringing geodata together with community knowledge, which is perfect because that's what we're talking about. And she's going to show us how she uses user-friendly apps in participatory mapping and storytelling. This is Esme.
Hi, everyone. So one of the key questions that drives my work is how can we improve decision-making by ensuring that experiences and voices of marginalized groups are well integrated and represented? Obviously, this is an age-old question that many people have been thinking about. But I feel, especially now with our talks on climate change, mitigation, adaptation, conservation, and how to include communities, this is something that is still very much present in our world. And there have been many approaches to this, but I've mainly been focusing on how we can use technology such as Google Earth to kind of bring more of an embodied experience, a more multisensory experience to decision makers, so that they really feel like they've been in those neighborhoods and feel like they know what's going on the ground. Because too often, decision makers actually don't have time or adequate resources to visit many of these areas. They don't know enough about the neighborhoods or the landscapes to make these decisions. Unlike remote working, then it's good to also be on the ground, but we can't all do that, especially during COVID. So by not reading conventional reports, but actually visiting these areas virtually through Google Earth, these decisions can be based more about what the residents want these people to see. And that kind of gives power to the residents who are creating these stories. And so this visual tool in Google Earth is also quite easy to do. It's very user-friendly, of course, as some might know. And you can use participatory methods such as Kobo Toolbox or ODK Collect to actually do this offline and in a citizen science type of way or with a community type of way. I'll give a little bit more of a specific example. So in my recent work, we use this approach to formulate so-called sponge town water management interventions in Kenya, in a town called Nakuru. In an informal settlement and low-income areas, the people mapped out in their area what were issues regarding floods, but also issues regarding shortage of water, and interventions that they saw their fellow neighbors or community members do that they thought inspiring and that they thought decision makers should pick up. Additionally, they also gave ideas on what they personally think would be great solutions. And so they co-designed the survey, they walked through the neighborhoods on their phones, and they collected all the data. And then they came together to select, okay, out of all the data that we've collected together, what are the key ones that we really want to bring forward to these decision makers, in this case, the county government that they presented it to. And the nice thing is, because of Google Earth, of course, it's an interactive project, people have ownership, maintain ownership of the story that they're creating, and they can change it as well and easily share. So this is an example of one of the parts of the story, the Google Street View you can see, that they have shared with the decision makers. As you can see, there are 21 points in the end that they wanted to use. And this is actually one that has been used by the decision makers, in this case the county government, The community said, okay, there's this old quarry in our area, and it has been a very difficult place for us, also a lot of violence, etc. If we can change this into a community park, it's both good for water capture, as well as in dry season, we can actually use this water for other purposes. And so this has been indeed implemented and taken up by the donors and by the county government, all because these community members came with the idea, which I think is a really cool way of using such tools. Another way of using it is actually in education. So for instance, in community engaged learning. So as my role at one of the universities in the Netherlands, University Utrecht, we have a field course in East Africa where the students spend a lot of time in informal settlements with their homestay hosts. And basically what they did was walk around with their hosts through this neighborhood to kind of map what is under these tin roofs. We always see these pictures of informal settlement, but what is the life that really happens down there? And when I was looking at their data, I felt like I have been there again. Like I've been there a few times, but not like that year. And when I was there, like watching these data points and like all these things that go on under these houses, you kind of feel it really comes to life. And that's the point. Basically, with the Google Earth, the way that you can use it with participatory tools combined with Kobo or other type of things, you can really bring this to life. You really feel like you've been in this area, and you really see it as a journey through the eyes of the resident. Thank you.
Thank you, Esme. It's so cool when we're so used to looking at like large-scale maps of geodata to see like very small scale, like what somebody's actually doing in the map. That's very cool. Yeah, our fifth speaker is Alta. Alta is an associate professor at the Center for Sustainability Transitions at Stellenbosch University in South Africa. She's a researcher and an educator. She's focused on resilience of protected areas and conservation systems. And she's going to talk to us about measuring biodiversity, right? Something like that. Yeah.
Good afternoon, everyone. We all know that in the Anthropocene, we are faced with a biodiversity loss crisis. It's part of the polycrisis that we have to navigate. And to navigate this crisis, we need data to understand how human land use impacts the biodiversity that also underpins human well-being. But in many places in the world, we don't have that data. We struggle to have the right data to be able to make good decisions at a policy level. And so this is also true for Africa. So the slide here is showing the Predicts database, which is probably the largest database arguably the largest database of this kind of like species data that can be used to measure biodiversity impact across the world. And this looks not too bad for Africa. It looks like there's some sites, but actually like this masks the fact that you not only need the actual biodiversity, the species data, the species abundance data, which is the really limited data that we often struggle to have, but that you need it in relation to a reference site, so either in time or in space. So to address this challenge in Africa, or for Africa, we took the position in this Biodiversity for Intactness for Africa project that whilst we might not have data everywhere in the continent, we do have really good expertise across the continent about like what species, how species are impacted by different kinds of land uses. And so what this project did is it convened more than 200 experts across the continent, or people working on the continent, across these 11 different taxonomic groups. And it ran a sort of a modified Delphi process, which is just a sort of a process where you ask people to kind of assess impacts on different taxa or different functional groups within the taxonomic species. And then, like you run several iterative discussions after that so that people kind of revise their estimates and kind of consider it very systematically. And so we ask them to do that. So we ask them to assess the impact of different land uses on different functional group within different taxa. So there were these different taxonomical sort of species expert groups. And then we asked them to rate that from sort of 0 to 1, 1 being kind of intact and 0 being like completely transformed. There were some modifications to that as well. And then we assembled that into a biodiversity intactness map for Africa. So this is both at the 1 kilometer scale and the 10 kilometer scale. The 1 kilometer resolution and 10 kilometer resolution, and then also broken down for the different taxonomic groups across the continent. So these data is currently reviewed. It's being published as a data paper. We've also made it available as a Google Earth Engine app, which can be, so the data can be downloaded. There's some sort of summary statistics that can be calculated in the app. And this is available. It's a work in progress, but it's available. And whilst we think that these data will be very useful across many different, for many different purposes, so for things like quantifying ecosystem integrity or condition across space and through time, for assessing the severity of functional decline for IUCN rates lists of ecosystems, for things like setting conservation and restoration goals, and we're monitoring progress towards these goals. I think the most important thing for us, or we think the most important contribution from this project is that it's compiled this, or that it's created this sort of list of African biodiversity experts. And so another sort of mini project that we did along with this rather bigger giant project is to also compile a story map that tells the story of biodiversity change through the eyes of these experts. So if you go to this Google Earth story map, you'll see the bio of all of the experts that contributed and their perspective of change in the landscapes in which they work. And so we hope this is a small step towards like bringing African assessment to the global assessment table. Thank you.
Thank you. It's always so impressive to hear like that people are experts about such specific things. Like how many frogs are likely there if you're growing fruit trees or something. It's pretty amazing. No worries. Our sixth speaker is Maria Olga Borja of Ecociencia, which is an Ecuadorian nonprofit working to conserve biological diversity. She's overseen the development of mapping projects of the Ecuadorian Amazon for map biomass, some of which are on Earth Engine, which is great. And she's going to be talking about mining.
Thank you so much. Well, thank you, everybody. Hello, everyone. Thank you for this opportunity to share our work with you today. I will be talking about how mapping land use change in the Amazon is helping us identify emerging trends in mining and how this data is turning into action by the local citizens. First of all, this work is the product of the Map Biomas Network and its Map Biomas Amazon initiative, of which I am proud of, and as part of, Ecociencia is part of. We are a collaborative network of institutions, NGOs, academic, and also technological startups. And we work to leverage remote sensing data and free processing platforms like Google Earth Engine to generate high quality temporal and spatial data. We are motivated by the possibility to turn science into actionable data, and we work in some of the most biodiverse regions in the world. Well, in the past, as you know, as you're all very familiar, understanding the drivers of land use change was very challenging due to the lack of information or its limited accuracy or just, its temporal and spatial discontinuity. So at Map Biomas, we're working very hard to change this. And we've used the Landsat Archive and Earth Engine to reconstruct the land use change history for almost the last almost 4 decades. And this is an essential step to understanding the current status of our remaining natural cover. And here you can see the Amazon, like the whole entire Amazon shared by more than 9 countries. And we are mapping at least 20 different classes in it. Of course, green is representative of forest. Our maps go from 1985 and they're yearly, and they're publicly available at our websites. As mining, it's one of the products of the classes that we're mapping, and this is the first time we're able to know where mapping is happening in Ecuador, in the Ecuadorian Amazon. We're not only that, but we're able to understand how is it growing, as you can see by the trend. And for instance, you can notice that it was growing steadily, but from 2015 onwards, it took like a really high steep, And it's sad to say it, but in the last 6 years, mining has pretty much quadrupled. We're also, since we're mapping more than one class at with very high precision, we're able to understand what types of changes mining is causing, this expansion of mining is causing. For instance, we know now, represented by that pie chart, that only of the areas that were mining expanded in 2021, at least half of them occurred where we had previously mapped forest. And we know this is, since we have a whole history of mapping, we know that this is a change that is happening right now. Not this much forest had been cleared before to change into mining. And this is a very worrisome trend that we're seeing now, mining turning into a direct cause of deforestation. Well, this data, when we combine it with conservation status and protection, like protected areas or indigenous territories or governmental incentives and all, it allows us to assess, strategies that we as a society can take to have the most impact. For instance, in the Amazon, we know that indigenous territories are the most effective strategy to protect the forest. We know that the social systems that are in place there allow for the ecosystems to persist and thrive. So, but even though the communities are fighting the threats of mining, with satellite means, we know that the mining is increasing within indigenous territories. And just last but not least, we're working to create connections and integrate with other projects to increase our impact. For instance, in this case, MapBioma's data was used to identify mining hotspots by other projects. In this case, for example, a MAP, environmental crime report. And we know that civil society is finding this information useful because, as you can see in the picture, one of the histograms, which is the end product of a long pipeline of processing in Earth Engine, was printed and used in a demonstration protesting the increase of mining in their communities. And this forced the Ecuadorian government to expel the illegal minings from this site. And sadly, this is not a happy ending story. Challenges are increasing and they're more significant, but this is driving us to create better maps and transform data, maps, science into actionable data, just like all of you here. Thank you.
Thank you. It's so stark to see the difference in the Amazon with where the mining has occurred. It's crazy. Our seventh speaker is Jonathan Pandoko. He's a visiting assistant professor at Clark University's GIS program. He specializes in remote sensing with a particular interest in socio-ecological systems and engages graduate students at Clark University in best practices in GIS software, geospatial programming, and cartography. You should come do office hours instead of me. He's completing his dissertation work through UCLA Geography, and you're also going to be speaking to us about a forest, but a slightly less well-known forest, the Los Angeles forest. Cool. Awesome. Thank you, John.
Thanks, Avi. So I'm coming straight off a collaboration with Los Angeles County, and they're facing some public health challenges with the changing climate. This includes extreme heat, increased fire intensity, prolonged drought, invasive species, and pests. Now, there's an existing infrastructure in place that has long been studied to provide ecosystem services to help mitigate a lot of these issues. This is the urban forest. And it's a popular sentiment right now that we should be planting as many trees as possible wherever, whenever we can. Now, as a former urban planner myself, current remote sensing scientist, I come at this with a different perspective. What species you're planting, where you're planting it, and why really matters. If we go about the more popular route, you're going to end up with a lot of dead trees. You also have to take into consideration who's going to be maintaining and managing those trees as well. The Los Angeles County Department of Public Health understands these trade-offs and is looking towards methods to help manage its 800,000 public trees. These are managed across 8 different county departments to the tune of just north of $5 million a year. And they've turned to remote sensing scientists like myself, asking whether we can build and automate a model to ID specific individual tree species, monitor them over time, so that we can answer the question, which trees, where, and why. So starting our model, we have to focus on the trees. So urban Los Angeles County is one of the most diverse urban forests in the world. Hundreds of trees to choose from, and anyone who models, the more classes you have, the less your accuracy. So we really went with our stakeholders and asked them which ones are most important to you. This spanned 11 target species and genera across non-native and native species. The natives were tagged for conservation opportunities within urban space. These are California natives. Non-natives, however, are culturally significant trees, such as the iconic LA palm tree, citrus trees, or potential hazard trees that might pose public health issues in the next fire or wind event. Then we wanted to look at the people. LA County is the most populous county in the US, and it's one of its most diverse. So we wanted to make sure we were capturing a representative sample of the people who are going to be maintaining these trees. And so this led us to 3 pilot sites. This includes Altadena, East Los Angeles, and Marina del Rey. Diverse trees, diverse people, diverse management practices. The data that we are using was a combination of 3D structural data, discrete return LiDAR captured by the county, and then also some optical 4-band imagery at 60 centimeters provided by the United States Department of Agriculture. We also have over 16,000 plus GPS logged tree locations for our target species across our 3 pilot sites. And then we brought them into some Google architecture. This included Google Cloud as well as Earth Engine, and we used 2 different model approaches, a 3D model, computer vision, as well as a 2D random forest. The results from our models will then hopefully help the county measure and monitor these target species to answer that question of which species is doing well, where, and why. So I don't have enough time to go into the methods in great detail, but I'll try and provide a really quick overview. So we start with our LiDAR processing. Then we fuse our optical data to that to the process LiDAR. That fused data is then our input for 2 different models. The first one is a 3-dimensionally computer vision model, and then the other one is a 2D random forest model. And this gives us 2 sets of results, one based in 3D, one based in 2D. This all happened entirely within a Google ecosystem. Google Cloud is great for LiDAR processing. It's great for that computer vision model. Earth Engine, great for 2D and bringing in that optical data, and for developing public-facing apps later on. But most importantly, as a grad student, thank you, Google overlords, for supporting education and research. So really quick, computer vision results, we were getting around 60% accuracy across all target species. Our random forest results, we were getting in the 80s. There's a bit of a discrepancy here. These are not discrete numbers. These are still models that we're working through, which leads us to next steps. We're continuing to collaborate with LA County. How do we deliver this data to end users? How do public works work with this? How do we begin to answer those questions of which tree, where, and why? And how can we fine-tune our models? And then my work at Clark University, specifically focusing on the computer vision fine-tuning. Thank you so much.
Thank you, John. It's cool seeing random forest classifier being used for random forests. That's actually, yeah, that's pretty cool. Our 8th speaker is Court Fowler, who's an app specialist with Blue Ventures, who, as you might guess, is focused on the ocean. And Court's an experienced computer programmer and a conservationist working in marine ecosystems and forests. And you're going to talk to us about some beautiful mangrove forests. Cool. Thank you, Court.
Oh, yeah. Okay, Blue Ventures. Yeah, so marine conservation. Blue Ventures is an NGO originally founded in the UK. And they basically, you can imagine where the equator is, and they basically work all the way around the globe on the equator. This particular shot is probably from Madagascar. And this is a mangrove forest. You can see that the water, salt water, comes right up to the bottom of the canopy. So these are really cool forests. And briefly about Blue Ventures, pretty much everything they do is locally led. So they come in and help people get tenure rights to the land. They help set up participatory monitoring of their resources, and they help people get access to climate finance. And mangroves and seagrass are two of their big focuses. And the blue carbon in these environments is incredibly rich. It's much denser than a lot of the tropical forests that are typically nearby. They provide coastal protection from things like cyclones and various storms that blow in off the ocean. They're incredibly dense with fish. I had the privilege to visit Madagascar for a few weeks this year, and just the density of life in the mangroves is unbelievable. Like you can't go into the mangroves without stepping on living things. It's unbelievable. So yeah, that's good for that slide. So one of the tools that Blue Ventures has is called the GEM, the Google Earth Engine Mangrove Mapping Methodology. And this is based on a study that was published in the journal Remote Sensing by some of my colleagues here. And this is a group of scripts in the code editor that you guys are all familiar with, I'm sure, the Google Earth Engine code editor. It's open source. It's free for nonprofit use. And yeah, this image here, this is some Landsat composite here that is produced by the GEM. And you can kind of see it here, this darker orange or almost red kind of edge on the coastline there. That is the mangrove. It shows up really, really well in this false color composite. And the GEM essentially classifies the territory. You can have any number of classes that you wish. Ideally, one of them is a mangrove of some sort. And yeah, we'll take contemporary imagery, compare it to historical imagery, and sort of tell you the dynamics over time, loss, gain, persistence, that kind of thing. This is really, really powerful. There hasn't been a lot of tools out there for mangroves in particular, and spotting loss in mangroves allows the local communities who live here, who rely on these mangroves, to address that. It gets them access to finance, which is a huge incentive for continuing their efforts of maintaining these forests. One of the reasons I'm here this week is because there's a new version of this tool, which is very, very recent. It's an app. It's a mobile app, and this is a really awesome new change because a lot of the places that Blue Ventures works, people do not have reliable internet. They don't have desktop computers, but everybody has a phone. So this puts these management tools right into people's pockets, right into their hands. It uses Google Earth Engine. You can see this is actually the exact same area, kind of zoomed out from that previous picture. But yeah, it stores the imagery from Google Earth Engine so you can look at it offline, that kind of stuff. And this is just one screenshot. There's a ton of screens, a bunch of different ways of looking at this data in the app. And if you come by the demo table tonight, I can show you more. And yeah, it uses some of these technologies down here, a bunch of googly stuff. So everybody should be happy about that. Yeah, it's a nice new thing that we just built. And I think that's good for that slide. This is just one sort of summary slide here, and just making the point about this kind of effort, the kind of work that Blue Ventures does. This tool is a tiny little piece of that. So there's really only 3 people who work on the GEM, really only 1 person who opens up a code editor, and almost everybody else, an organization of over 200 people, almost everybody else is actually hired by hired by Blue Ventures because they are in the community. So engaging with the community happens in a very, very direct way. And these tools are, obviously very powerful, very useful, and we're incredibly thankful to Google for making this kind of stuff available for free. But it wouldn't be possible to protect these forests without a ton of very messy, muddy labor out in the woods. And I just want to, that's what this slide is just reminding us all of. Let's see. Oh, this is the final slide. So we got a few links here, and you guys will all have access to the slides. But there's the study in the middle, that MDPI, and there's the GitHub. And eventually, when the app is published, there'll be a link for that too, but not today. All right. That's it.
Thank you, Court. Really cool. That looks beautiful. Our ninth speaker is Dr. Elizabeth Medin, an associate research professor at the Institute of Marine Biology at the University of Hawaii. Dr. Medin researches how human impacts can cascade through ocean ecosystems through changes in animal behavior. She was recently awarded an NSF Career Fellowship to develop a satellite and drone imagery-based conservation tool. And she also works with a community group in Kailua aiming to end overfishing and to restore the local coral reef ecosystems, which you're going to talk to us about. Thank you, Liz.
Okay, thank you very much for the intro. So in my lab at the University of Hawaii, we focus on landscapes of risk. So for example, predator-prey interactions, large-scale human impacts, and new and emerging in the marine system technologies with the idea of putting these towards conservation tools. And today I'm going to talk a little bit about what can seascape-scale vegetation patterns tell us about coral reef health. So as most of the people in this room would know or could surmise, overfishing leads to predator loss, and protection, conversely, from fishing can lead to predator recovery. And on coral reefs around the world, overfishing is a widespread issue. And so we're interested partly in understanding how do humans affect ecosystems through predator-prey interactions. And so humans have effects on ecosystems through this fishing pathway, for example, because we tend to focus first on predatory fishes. We like to eat those more. That can change the behavior of small fishes. So for example, a fish going out from its home coral shelter to eat seaweed. In a sense, when we take out these predators, creating like a fearless fish. And this can have effects on the distribution of the prey's food through this pathway called risk effects. Now, a few years ago, some colleagues and I developed a random walk model that tried to capture this in a very simplified sense, so that we have coral reefs that are the little blobs you see here, and that if fish are tending to stay close to those when predators are around, it creates these safe zones. And those safe zones are where the fish tend to eat, and so those are devoid of seaweed or seagrass or algae. And so what we see is when we look, this is just from Google Earth, I think in the Red Sea, we see these areas from just above looking at a reef here with that safe zone, and then the risky areas in between reefs, which are covered in usually some sort of seaweed, seagrass, or algae. And these safe zones are what is known as a halo. Now, halos have been known for about 60 plus years in the Caribbean, but what the cool thing is now we can actually see them from looking down, thanks to Google Earth. So I'm going to have to try and play this, see if it'll work. Let's see. Okay, yeah. So thanks to Tyler Erickson for doing this a few years ago. So what we did is we went to the Great Barrier Reef, looked at a bunch of big reefs like this, and went to the small patch reefs. We outlined those in red, the halos in green, and we measured them for lots and lots of reefs. We did this all manually, which, as you can imagine, for all these reefs took a very long time. And so that's the Great Barrier Reef Marine Park in red there. And what we found is that, as reserves, I skipped a little bit, but whatever. As reserves get older and predators recover, halos are more likely to occur. So that was kind of interesting, and it led us to think, okay, maybe these halos can be used as the basis for a remote monitoring tool. But we needed to know, can they be used as indicators of healthy reefs? For example, here's a snippet of an island in Indonesia, which is probably experiencing heavy fishing pressure. But before we do that, first we need to know, for example, what is their global distribution? Are they found everywhere? How common are they? What's their long-term persistence like, and do we see short-term changes? And so what we've done with the assistance of my amazing lab tech, Aviv Swan, he went and used Google Earth, and every degree of latitude going out from the equator into the subtropics, he looked in every single reef he came across. He looked and saw how many halos there were, what was the area covered, and so on and so forth. And so it turns out that they're actually found everywhere. They're even more common than we expected. So just briefly, on the y-axis, we have the percent of reefs that we saw halos in. They're found in every ocean basin, and particularly in the North Atlantic. And really about 10% of the world's reefs have halos, which actually goes up to 20% when you look at only the reefs that have the prerequisite patch reef habitat. So that's a lot. I'm just going to skim through this, but basically when we did this global survey, what we found is here, on the y-axis of this plot, you can see its halo presence. So when you have lots of fishing, these are areas that are unprotected. When you have some fishing, there's some halos, but when you have no fishing, there is about twice as likely to have halos. That's the same thing for halo area, same pattern. And then we also saw that as reserves, marine reserves get older, we see more halos. So we found that halos are most common in large, fully protected marine reserves, suggesting that they can be a useful conservation tool. So then my postdoc, Simone Franceschini, this year published a deep learning model for measuring coral reef halos from imagery because it takes so long to annotate them manually, and I'm not doing that again. So basically, it just speeds up the process dramatically, which is great. We did that on Planet imagery. So now, as a last step, what we're doing is developing this tool. And for example, for the proposed Pacific Remote Islands National Marine Sanctuary, we are trying to scale it up and make it into a pipeline that will be easy to use for people who don't want to work on the back end of it all. Just pipe their imagery into pipe their imagery into our platform and get out an answer to tell them over space or time, how are their reefs faring? And I have a lot of students and postdocs working on the nuance of that. So with that, I'd just like to say thank you very much and hope you enjoyed it.
Thank you, Liz. You always forget how much of civilization is predicated on fish being scared enough. Our 10th and final speaker is Olga. Olga is a technical product manager at Restore in Switzerland, which is a global network of conservation and restoration projects. She's been focused on large-scale geospatial processing and remote sensing analysis, working to improve land cover mapping, and she's going to talk to us about her work on Restore.
Thank you. All right, this is the last talk. My God, the lights are so... So I'll be talking about the platform, and it nicely wraps up all the session because some of you are already on Restore and the Cayenne Botanical Garden. You are having point of interest on Restore, and I want to see that profile going up. And some other restoration work is happening here. What I'll be talking about is an interesting topic because restoration movement can be a lonely journey. When you start it as an individual or one person, you don't know where to start, you don't know where to join, and you don't know what the next step should be. So my journey had started, I'm originally from Ukraine, and over 10 years ago, I moved to Austria. There I was working on remote sensing, mapping deforestation, focusing on Southeast Asia. And what I've seen on those satellite images was devastating. There were fires, there were plantations, and papers are good, and the science moves things forward, but I felt there needs something to be there to call to action. At the same time, I was living next to this park, which, you go for runs, you go for a swim, and you really enjoy this place being next to you. Little I know that 30 years before, that was a clay mine that by city of Vienna in Austria was restored to this beautiful, very biodiverse area. And this is equivalent of 100 football fields, so not this small area. At that point, being frustrated by all these topics, I come across the project called Restore, and it's been over 3 years ago, and I joined this. Less than 3% of Earth's land remains ecologically intact. There is over 700 billion needed to halt biodiversity loss, and there is very little, there is a lot of resources to unlock to support this journey, to support these projects all over the world, but there is little transparency, there's more need for trust. And the idea of the Restore is to build this open digital platform that would help restoration get the visibility, demonstrate impact, and create a sustainable livelihood, because restoration often can be a lonely journey. So as a Restore, we are focusing on the transparency, science, and at the scale. So by transparency, it means as a project that organization joining Restore, you can set up your profile, you can draw the boundary there very, very easily. You can add information about and the photos of your project, and that can help you to show your work to the world, to show your work to the funders, but also to connect to other people that may be in the same area or same country or the district doing similar work and learn from them. You can see the time series data, you can show your progress, and you can build the trust, and you can make your work more transparent. Science, you can go and Restore, you can draw a little polygon within like 3 seconds, you'll get numbers about the biodiversity, carbon, water for your particular area of interest. I get asked about marine projects and so on, would love to talk about that. We have mostly focusing on the land projects, and this data would be available for you for free. And scale, at Restore, there's over 135,000 projects worldwide. And the last time I looked, there were 1,500, around 60 organizations when I made the slides. Today I looked, there's 1,570 organizations on Restore. So we get 2-3 organizations every day registering and setting up their profile and showing their work and showcasing their work. I updated this slide, 140 countries. We are in 7 languages. We are aware that not everyone speaks English, and you can read the profiles in the language you prefer. Hopefully, it's one of those 7. I encourage you to find where is this page with all the organizations and filter based on the country and see what the work is going on around you and how you can support them. And it's usually what motivates me when I wake up to work and do product manager work at Restore and do some Earth Engine coding with the backend and all sorts of things that you do in the startup as you do. We are a non-profit startup. It's coming across this kind of stories where, for example, Alejandro Sugasti 10 years ago bought the land for the agriculture, realized how biodiverse that area is and turned it into being restoration sites and figured out how to do restoration, agrotourism, and preserve the areas that he cares about. Or my absolute favorite organization, Restore, a very small organization in Australia that is focusing on koala restoration land and preserving those areas. So my name is Olga Danilo. Find me if you want to talk a little bit more or if you want a personal demo. And encourage you to go and Restore, find your favorite organization, and share that with me over the coffee break. Thank you.
Thank you, Olga. It's so cool to be able to see all these groups that are working on restoration in one place and for them to be able to connect with each other. So we have a 15-minute break. Thank you to everybody who spoke. I mean, all those organizations are doing incredible things, and I learned so many things about mangrove forests and scared fish and incredible things. So thank you all so much, and feel free to come forward and ask all these people questions. I'm sure they'd be happy to answer any questions you might have. Thanks, everybody.